There's this like deep-seated habit in the tech world.
Oh, absolutely.
It's almost this biological drive toward tribalism, really. We see it everywhere right now with artificial intelligence.
Yeah, people love to draw these rigid battle lines in the sand.
Exactly. They fiercely argue over which single AI model is, the absolute best.
Like it's a zero-sum war or a spectator sport. Everyone wants to declare a definitive winner in the arena.
But framing it as Claude versus GPT is just a false choice. We are asking the wrong questions entirely.
Completely agree.
Welcome to the deep dive. We have a really fascinating mission for you today. We are exploring a document called Hybrid Intelligence.
Which is a brilliant read, by the way.
It really is. It outlines a highly specific framework known as the Fable 5 and GPT-5.6 workflow.
And this approach, it kind of fundamentally changes the math of software development.
Right.
It completely dismantles that tired debate. You just don't have to choose a side when you can engineer a system where both models compensate for each other's weaknesses.
And that is the philosophical core we want to unpack for you today. We are going to explore a 4-stage autonomous system called the Me Codex workflow.
Yes, the Me Codex.
And then we will look at how it survived contact with reality in a real test case called Trip Atlas.
Which is where the theory gets brutally tested. It takes the abstract architecture and just forces it to build a functioning application.
So I want to start with the underlying philosophy. Why do we even need to combine these models?
That's the main question, right?
The current discourse usually pits GPT 5.6 Devil against Claude Fable 5.
Yeah, some call it Codex versus Claude Code.
But asking which one wins ignores how artificial intelligence actually reasons.
If we connect this to the bigger picture, the right question is about routing.
Routing, exactly.
Which model handles which specific part of the cognitive load? Because, their internal architecture is optimized for entirely different tasks.
Let's look at the raw computing power first. OpenAI just published the early benchmark numbers for their new tier of models.
The Sol and Ultra models.
Right. And GPT 5.6 Sol and GPT 5.6 Ultra actually beat Claude Mythos on Terminal Bench 2.1.
That metric is crucial here.
Let's clarify that for a second. Terminal Bench 2.1 is a standard test measuring how well an AI writes code.
So the GPT models are demonstrably pulling ahead on pure execution.
Yeah.
Now, launch benchmarks are usually heavily curated by the parent companies.
Sure, of course.
But the underlying signal remains undeniable. The GPT 5.6 architecture is an absolute powerhouse for generating syntax.
But raw power is only one variable in the equation. The other variable, which often dictates reality, is cost.
Oh, massive factor.
Token efficiency completely changes how we build things.
It dictates what is actually sustainable for developers.
Right.
Fable 5 possesses incredible capabilities for deep multi-step reasoning. But if you force Fable to plan the app, write the code, fix the syntax errors,
and review the final output.
Exactly. You burn through your token limits instantaneously.
The economics of this workflow are just fascinating. Let's look at the actual numbers. The older generation, GPT 5.5 Extra High, cost $1.24 per batch.
Yep.
And it scored 23% on the benchmarks. Now look at the new GPT 5.6 Sol.
The jump is crazy.
It costs just 56 cents, and the score jumps to 25%.
So the price drops by more than half while the performance increases.
Which creates a massive arbitrage opportunity.
Exactly. That mathematical reality is why Codex becomes the optimal layer for the actual building phase.
It makes complete logical sense, but I have a vulnerable admission to make here.
Oh, yeah.
I still wrestle with this habit myself. I catch myself forcing a single AI to do absolutely everything. I burn my API budget just because it's easier to stay in one single chat window.
Oh, we all fall into that trap.
Yeah.
Humans naturally gravitate toward a single omnipotent tool.
We really do.
We just want a magic box that handles the entire pipeline for us.
But relying entirely on Fable 5 for basic boilerplate coding is deeply inefficient. It is like paying a master architect's hourly rate to hammer nails into drywall.
That's a great way to put it.
Fable should do the expensive, high-level thinking. Codex should handle the cheap, repetitive building.
Right. The architect shouldn't be pouring the concrete. That division of labor is the secret to scaling these applications without going bankrupt.
So are developers already trying this advisor mode where they manually split the planning and execution?
They attempt it, yeah. But they usually construct the pipeline backward.
How so?
They use a powerful model for the initial planning, which is good, but then they route the actual coding tasks to Opus or Sonnet. They completely miss the economic advantage of utilizing the cheaper Codex engine for the heavy lifting.
So Fable does the deep planning, and Codex handles the cheap execution.
That is the exact formula. And understanding that economic reality brings us to the actual mechanism.
Which is how we extract those flawless blueprints from the architect in the first place.
Right. We need a rigid system.
Which brings us to the core of the document, the Me Codex workflow.
It is a highly structured 4-stage process. The first 2 stages are entirely dedicated to preparation.
Stage 1 is the interview.
And this kind of flips the traditional dynamic, doesn't it?
It does. You initiate the system, but Fable refuses to write any code.
Which is so counterintuitive.
It is. But a classic mistake with autonomous agents is that they rush into building based on a vague prompt. They hallucinate the missing details.
Instead, Fable just halts the process and interrogates you.
It generates about 8 to 10 highly specific questions. It analyzes your initial prompt and searches for ambiguities.
Like asking who the target demographic is.
Exactly. It probes into your preferred tech stack.
It forces you to define the boundaries of the product.
It demands clarity. It will ask how the back-end data flow should be structured. It questions your API choices.
Right.
It even asks you to define the edge cases or what features can be safely skipped for the version 1 release. But what happens if a beginner doesn't know the tech stack answers in stage 1? Say they want a highly secure enterprise backend, but ask to skip user authentication for version 1.
Fable anticipates those exact contradictions. It doesn't just blindly accept your input.
So it guides them.
It provides curated recommendations for every single question. It resolves architectural conflicts before they even enter the code base.
Right. The AI gives you multiple choice options so you never get stuck.
You just select from the expert parameters it calculates for you. This guarantees the context window is loaded with a coherent, logical foundation.
That structural integrity is vital. So the interview concludes. Fable now understands the precise boundaries of the app.
Which transitions us right into stage 2, the debate.
Yes, the debate. Fable drafts a comprehensive build strategy based on those parameters, and then Codex attacks it.
Codex assumes an adversarial role here. It actively hunts for vulnerabilities in Fable's architecture.
It spans for race conditions in the logic.
It highlights potential memory leaks. It points out missing dependencies and structural weaknesses.
And Fable doesn't just accept the critique, it actually formulates a defense.
Fable evaluates the feedback. It might adjust the blueprint to fix a vulnerability, or it might push back.
Like explaining why Codex's concern is invalid given the broader context.
Exactly. And this adversarial loop can iterate up to 5 times.
I have to push back on the mechanics of this, though. Doesn't a 5-round debate just delay the actual project? It feels like unnecessary friction.
I get that, but that latency is a feature, not a bug. When you really think about it, whoa, imagine 2 genius AIs arguing to perfect your idea before writing a single line of code.
It is a stunning concept when you frame it like that.
That upfront friction prevents hours of painful human debugging later.
It is a profound shift in how we view time. They are having the complex, difficult conversations before the foundational concrete is actually poured.
It hardens the architecture. It ensures the blueprints are virtually bulletproof.
And only after the models reach a consensus does the system allow the execution phase to begin.
Which introduces the second half of the framework, stage 3 and stage 4, the execution and the review.
The theoretical planning ends, and the handoff finally happens. Stage 3 is the build phase.
Codex takes full control of the terminal. This is the GPT-5.6 Sol engine doing exactly what its architecture was designed to do.
This keeps the token consumption strictly managed.
That is the economic engine of this entire workflow. Fable handles the high-margin, expensive reasoning upfront.
And Codex executes the repetitive, high-volume token generation.
You get premium software architecture for a fraction of the computational cost.
It is fascinating to watch the models stay in their respective lanes. So Codex finishes generating the syntax, the files are written.
That triggers stage 4, the review. Fable re-enters the arena.
Fable comes back as the ultimate inspector.
It analyzes the newly generated files. It runs a comparative analysis between Codex's actual output and the blueprints they agreed upon in stage 2.
It hunts for any unfulfilled requirements or lazy implementation choices.
Yes.
This dynamic is exactly like a senior developer reviewing a junior engineer's pull request. The senior dev designed the system, the junior dev typed the code, and now the senior dev is auditing the final product.
It mimics human engineering hierarchies perfectly. The reviewing model maintains the overarching vision that the executing model often loses track of.
I wonder about the mechanics of the failure state here. Is there a risk of the models getting stuck in an infinite loop of sending code back and forth?
That is the primary danger with multi-agent systems for sure. But this framework employs a hard-coded safety mechanism.
A limit on the revisions.
Yes, Fable is only permitted to send the work back to Codex a maximum of 2 times. It is an absolute 2-strike rule.
Just 2 strikes for Codex, and then Fable steps in to fix it.
An orchestration script monitors the retry count. If the code remains broken after the second revision, Codex is benched.
And Fable assumes direct control of the terminal.
It resolves the lingering issues itself. This guarantees the project doesn't endlessly iterate. It actually ships.
That orchestration layer prevents the system from spiraling. Sponsor. So, theory and architectural diagrams are intellectually satisfying. But we need to examine how this hybrid system holds up under actual pressure.
How it navigates a real chaotic development environment.
Exactly. And the source material provides a highly detailed analysis of this exact scenario. They documented a live test case called Trip Atlas.
Trip Atlas, a stylized, interactive web application designed for complex trip planning.
The requirements were intentionally demanding. The user wanted a tool to add diverse destinations.
They wanted to inject specific travel activities.
And the defining feature was a cinematic visual replay of the entire itinerary.
What fascinates me is the initiation sequence. You don't write a complex, multi-page prompt.
You just trigger a single command, /grill-codex.
And you kind of just hand over the steering wheel.
That single command initiates the entire 4-stage pipeline. Stage 1, the interview, engaged immediately.
Fable began generating its clarifying questions.
It asked a very revealing question right away. Is this a real personal tool or a demo app?
Which fundamentally alters the database architecture. A demo app uses local storage, while a real tool requires a scalable cloud backend.
It also asked, how should geocoding work for new destinations?
Let's define geocoding for context. Converting street addresses into exact geographic map coordinates.
That is a highly specific technical hurdle. Fable was anticipating the complex math required for map rendering before a single line of code was drafted.
And remember the mechanism we discussed earlier. Fable provided multiple choice recommendations for handling that geocoding logic.
The user didn't have to invent a solution.
They just guided the AI's architectural choices.
That context was loaded, and the system moved into stage 2, the debate phase.
For Trip Atlas, the adversarial loop only required 2 rounds before the models reached a consensus.
But those 2 rounds were incredibly dense.
Codex aggressively challenged Fable's initial data structures.
The documentation notes they integrated 12 specific findings to harden the data core. 12 structural vulnerabilities patched before the terminal was even activated.
They cleaned up the underlying state management. If your data structure is flawed, adding or removing destinations later will completely break the application.
The debate phase ensured the foundation was rigid. Then the system transitioned to stage 3, the build.
The user is given options here, but they let Codex handle the execution. Codex absorbed the hardened blueprints and began rapidly generating the React components.
And the state logic, which leads to stage 4, the review.
Codex deployed the code, and Fable returned to audit the repository.
Fable identified several deviations from the original architectural plan, but it didn't blindly reject them.
No, it ran a contextual analysis. It determined that Codex's on-the-fly adaptations were logically sound.
It understood the context instead of rigidly enforcing the blueprint.
It acts like a rational senior engineer. It verified the mechanics, checked the file structures, and then prompted the user to commit the final repository.
But I have to maintain some skepticism here. Was this application visually flawless on the very first try?
The author is very transparent about this. No, the user interface was not a polished masterpiece.
It had some rough edges.
The styling was somewhat rudimentary. It required human intervention to refine the CSS and the visual margins.
That grounds the experiment in reality. But underneath the styling, the core mechanics actually functioned.
The complex mechanics operated flawlessly. It rendered a functional, interactive world map.
It dynamically generated custom graphics.
The state management allowed users to seamlessly add, remove, and reorder complex stops like Tokyo without crashing the application.
I am particularly interested in the cinematic replay requirement. How did it handle the visual animation?
It successfully generated an SVG plane to visually travel between the coordinates.
Let's clarify what that means. Math-based vector graphics that scale perfectly without pixelating.
Exactly. It mathematically calculated the trajectory between the geocoded stops and animated the SVG graphic along that path. It even triggered small passport stamp visual effects as the plane reached each destination.
Engineering that coordinate math autonomously is deeply impressive. But we need to look at the economic reality. What was the final computational cost for all of this?
This is where the hybrid theory proves its ultimate value. The entire Fable side of the operation, the deep interview, the debate, and the review, only consumed roughly 130,000 tokens.
That is an astonishingly low footprint for an application of this complexity.
It really is.
So what is the ultimate takeaway from this Trip Atlas experiment?
It empirically proves that you can translate a vague, unpolished idea into a complex, functioning application while entirely bypassing the massive token costs usually associated with advanced reasoning models.
You keep token use low without sacrificing that high-level reasoning and planning.
You leverage Fable for its elite cognitive capabilities, but you completely insulate it from the expensive high-volume generation that Codex is optimized for.
So zooming out from the token economics and the specific code bases, what is the larger philosophical shift here?
What it means for how we interact with these systems.
Yeah. The main takeaway isn't about declaring a victor in the Claude versus GPT proxy war.
The victor is the user who stops treating these models as isolated monoliths. The real breakthrough is adopting a localized ecosystem mentality.
You orchestrate a workflow where each intelligence operates strictly within its optimal domain.
You utilize Fable 5 for its profound judgment,
Its ability to interrogate a prompt.
and its capacity to review complex interconnected systems.
And you route the heavy lifting to GPT 5.6 Sol, utilizing the Codex engine for fast, highly efficient, and economically viable execution.
It is the ultimate division of synthetic labor.
It really is. I want to leave you with a final expansive thought today, something to mull over as you analyze your own technological habits.
Yeah.
If these AI models are already successfully debating each other, if they are identifying edge cases, pushing back on logic, and autonomously auditing each other's code to build our applications today,
Right.
how long until this architecture scales? How long until these models start autonomously hiring other highly specialized micromodels to complete massive, multi-layered enterprise tasks without us even prompting them?
Once the orchestration layer becomes fully autonomous, the ecosystem expands exponentially. The models will build their own specialized pipelines.
They will construct their own tribal alliances. So, here's your challenge for the week. Audit your own daily workflows.
Find just one complex task where you are stubbornly forcing a single tool to process the entire pipeline.
And experiment with splitting the cognitive load. Try assigning the planning to one highly specialized tool and the execution to another.
See what happens to the quality of your output.
See what happens to your underlying costs. It might fundamentally change how you engineer solutions forever. Out to your own music.